Hi there, this lesson is all about using inverse operations to check your problem. Now, what does that mean exactly? Well, we're going to find out, but just know that our goal is to understand how to use inverse operations to evaluate or solve a problem using inverse operations. So that's what we're going to do. The skills that you will need to use or the practices. We do need to persevere in problem solving. That's always a must. We're going to keep going. We are going to think about what makes sense. We're using this strategy to check our work. And as always, we are looking for patterns or connections in operations. And this is also an example of using reasoning, talking and explaining our thoughts. Here's a problem that you recognize. We've learned 3 different ways to strategize problem solving. Now, I know you're saying, well, you wrote strategies. Yes, we've learned 3 different ways or multiple ways to strategize, and we're going to list them as strategies. So one of the ways is the standard algorithm. We have also used, don't forget the M, Miss Addison. We've used the standard algorithm. We've also used partial quotients. We have also learned estimation for solving and checking. And today we're going to add another strategy, which is inverse operations. Now I'm going to highlight the ones that we use for checking. You can use partial quotients to solve or to check. You can use estimation to solve or to check. And you can use inverse operations to check only. And then standard algorithm is to solve only. So notice our highlights. Partial quotients and estimation can be used to solve and to check our answers. The standard algorithm is used only to solve, and then inverse operations are used only to check our answers. So we remember this problem, 890 divided by we would go 20 times this added the is 32. Now, we can use inverse operations to check our answer. For example, if this is true, okay, if this is true, then I should be able to multiply 20 by 43 and add 32. And if I am correct, it should equal 892. Let's check and see if that's correct. 43 times 20. Is it 892? No, but it should be 860. And we're going to use we could use the standard algorithm, but just like we said, for our math practices, we are looking for structure and repeated reasoning. So when I look for structure and repeated reasoning, I know that 43 times 20 is really 43 doubled with a 0. So it's 860. Why is that true? Because we know that multiplication is just repeated addition. 43 plus 43 is 86. And then we learned in chapter 1 about the little rule about the 0. So we have 860. We should be able to add the remainder, which is 32. Is it 892? Yes. So we've used an inverse operation to check the answer to see if we are correct. Now, we've got the Asher problem again. Out of good practice of problem solving, I am still going to do cubes. I'm going to circle important information. I'm underlining the question. I am looking for keywords that let me know what I need to do. I'm looking for how many cranes. So I'm boxing the action words, or the words that tell me what to do. And then E, I'm going to evaluate or execute my strategy and solve. So 1,638 divided by 42. Remember what we did the last time. We said, okay, I know that it would go in about 3 times, and then I'm going to subtract. And that should give me, because I'm regrouping here, 378. And I remember that 42 goes into 378 9 times. And 9 times 42 is 300. Oh dear. 378. And I have no remainder. If in fact my problem is correct, then 39 times 42 should equal 1,638. So let's multiply. Quotient times divisor should equal dividend. Let's try it. 9 times 2 is 18. Regroup the 10. 2 times 3 is 6. Plus 1 is 7. 9 times 4 is 36. Regroup. 4 times 3 is 12. Plus 3 more is 15. Now we're going to add. Bring down the 8. 7 and 6 is 13. Regroup the 100. That's not a 10, it's 100. 1 plus 5 is 6. And then we have 1,000. 1,638. I am using the inverse operation, which is multiplication, and I can conclude that my quotient was correct because I was able to get, when I multiplied the quotient times the divisor, I got the dividend. Yes, good job. I want you to try this on your own with this problem and see how you do. Remember to use the strategies that are available to you. What are you going to use to solve the problem? Are you going to use a standard algorithm, partial quotients, estimation, and what are you going to use to check? Will you use any of these strategies? Well, hopefully, because of our learning goal, you'll choose to use the inverse operation to check your answer. Pause the video and then come back to see if you got it right. Okay, here is the answer. You should have regrouped. No, you should have gotten a remainder, not a regroup. You should have gotten a remainder of 41 and your quotient should be 50. Now, how do we verify that that's correct? We should be using inverse operations. Remember, multiplication is the opposite of division. So we can use multiplication to check our answer. 50 times 97, and then we add 41. Does it give us our dividend? Yes, it does. This is a great way, boys and girls, to check your answer to see if it's right. If I had multiplied the divisor and the quotient and then added, I should have a multiplication symbol there. If I multiplied the quotient times the divisor and then I added the remainder at the end and I did not get the dividend, then that means I've done something wrong. Maybe I'll show you a quick example before you note if you got the problem right or wrong. Let's say I was going to do 9 times 6. or, oh, I just gave it away, but 9 or 54 divided by 9. And I would say, okay, how many times do I think 9 goes into 54? Let's say that I said, oh, okay, 9 goes into 54 8 times. Okay, I think I know my math facts and I'm just randomly multiplying. And then I say, okay, 8 times 9. And let's say I don't want to assume, so I'm going to draw myself a little picture. So I'd say, okay, let me get the number 8 groups of 9. So I'd say, okay, 9 plus 9 is 18, 9 plus 9 is 18, 9 plus 9 is 18, 9 plus 9 is 18. So I have 18 4 times, and then I added them all up. 8 plus 8 plus 8 plus 8, 16, plus 16 is 32. And I put the 3 here. That's 72. Uh-oh. I can't be right, because when I multiply, I get 72, and I'm supposed to get 54. That means that my quotient is wrong, and we all know that is incorrect, because 9 times 6 is 54, not the other way around. Hopefully you understand. If not, write down your questions to ask your teacher tomorrow. Check and see where you are on your scale so that you can make your questions known, and so you know which group you should be in tomorrow and receive assistance. Thanks for watching.